Hello.
Hello.
Hello. Good afternoon, students. So in last class, we learn about the different types of control systems, how they can be classified based on various factors. Control systems are classified into different types. And today we discuss about the open loop and closed loop control systems. Okay. So here the closed loop system and open loop system. All of you mute your mics. Hello. Please mute your mics. Everybody mute yourself. Some noise is created. Okay. Now today we're discussing about the open loop control system. The system in which the output has no effect on control action. That means the output is not depends on the controlling signal. Simply the output is coming as per the input is given. Here there is no controlling system or controlling mechanism. Such system is called a open loop control system. In other words, the output is neither measured or fed back or compared with the reference input. And here there is no comparison. What the output we get, it is never compared with the reference input. That means here the output is no effect on the control system or control signal or control action. Here we have the some block diagrams here. So this is the controller, and here we give the reference signal or reference input. Generally, the reference input is also called a excitation input to excite the system. And here it is the controller which generate the activating signal. So which is activating the uh, controlled process or activating the system. Then we get the output. So here there is no feedback here. So feedback, or sometimes it is also called a feedback. So that means feedback is nothing but a fraction of output signal is fed back to the input to compare with the reference signal or input signal to generate the error signal. So therefore, the mixer which is mixing the feedback signal and the reference signal is called as a comparator, or sometimes called as a error detector. So the error detector is generate the activating signal. So therefore, here in the open loop control system, there is no feedback here. There is no feedback path. So because the output, due to that reason, the output is not affected by the control action. So this is nothing but a simply open loop control system. For example, we consider a washing machine. So manual washing machine. So that means the manual washing machine is only perform the choking, washing of the clothes. It's not uh, get the proper output. The get the proper output in the washing machine is nothing but cleanness of clothes. So the washing machine does not control the cleanliness of the clothes, but simply it is operated choking and washing. But it is not controlling the how the clothes are cleaned, how much the clothes are cleaned. It is not done in the washing machine particularly. That is nothing but a open loop control system. Sometimes there are closed loop control systems in washing machines also. Sometimes the washing machine is also taken as an example for a closed loop system also. Okay, now here we talk about the open loop system. That means, again I repeat, in open loop control system, the output is not affected by the control action. That means there is no feedback. There is no feedback in between the input and output. So then it is called open loop system. Okay, now simply now I okay. So next one, these are the advantages of open loop system. Oh, the designing of open loop system is simple and easy to construct. That is, the open loop system is a simple design and easy to construct. So economically, it is the to construct the open loop system uh, uh, having the less expensive. That means it is economical, and then one is easy to maintain. The third advantage of open loop system is easy to maintain and highly stable operation. Highly stable operation. These are the advantages of open loop control system. Now there are disadvantages also. Here the disadvantage is not accurate. Sometimes we never get the desired output because the output is not affected by the controlling signal or controlling system. So therefore, sometimes the output is not accurate or reliable when the input or system parameters are available in nature. Okay, and recalibration of parameters are required time to time. That means the calibration, already we know calibration is nothing but how the that means it is errorless. Calibration is nothing but to set the or to what is meant to set the measured quantity as minimum as possible. That is sometimes we call as a calibration. So here in the open loop system, the calibration is always done repeatedly or time to time, recalibrate the parameters of the system. So this is about the open loop control system. Okay. Now closed loop control system. So here the closed loop control system, the activating error signal, which is a difference between the input signal and feedback signal. So already here we have the block diagram. For example, this is the system. So this is the comparator, or sometimes it's also called a error detector. So here there is a feedback path.
Sir, doubt, sir.
Between the, hello, please. Hello.
హలో సార్ ఓపెన్ లూప్ అప్లికేషన్ చెప్తారు ఒకసారి
ఏమా
ఓపెన్ లూప్ సిస్టమ్ అప్లికేషన్స్ చెప్తారా సార్ ఒకసారి
Okay. We discuss the applications later. We take the so many examples. For example, clearly I give the simple example. So in open loop system, for example, we have two types of hotels. అర్థమవుతుంది కదండి, two types of hotels. One is the general roadside canteen. It is one canteen, and the other one is the 5-star canteen. For example, in roadside canteen, there is no feedback system. How much tiffin is sold is not known up to the last day. But whereas in the high-end hotels, you give the tokens, and every time you know how much is sold, how much tiffin is sold, how much quantity is sold. That's a simple example. We can take so many examples. We discuss all the examples with open loop and closed loop. We have the concept here. Examples of open loop and closed loop. At that time, I clarify the your doubts. Okay.
Yes, sir.
Okay, amma.
Yes, sir.
మనకు ఆల్రెడీ కాన్సెప్ట్ ఉంది, ఎగ్జాంపుల్స్ అబౌట్ ద ఓపెన్ లూప్ సిస్టమ్ అండ్ క్లోజ్ లూప్ సిస్టమ్. సో ఆ కాన్సెప్ట్ వచ్చినప్పుడు మీకు క్లియర్ గా నేను ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే అండి. హలో, shall I continue?
Yes, sir.
Okay, thank you. Okay, so here in closed loop system is simply it consisting of a feedback path. That means always we can estimate the output signal to desired quantity or desired value. So for this purpose, we are using a feedback path in between the output and input. That means we take the fraction of output signal, head back to the input, and we generate the activating signal. That activating signal is nothing but a controlling signal. That controlling signal is controlling system for desired output. When we get the desired output, the error signal or the activating signal which is generated by the comparator or error detector is 0. That means we get the desired output. That means there is no difference between the reference signal and the feedback signal. If the reference signal is equal to the feedback signal, that means we get the desired outputs. That is the major advantage of closed loop system. So here in closed loop system, the activating error signal, which is the difference between the input signal and the feedback signal, that is called a controller signal or error signal, which is used to control the system to get the desired output. So here we have some block diagram here. So this is the input, this is the input, and this is the feedback signal. So here we have the feedback signal is compared with the input signal. Then we generate the activating signal or error signal. So by using this error signal, we can control the system up to we get the desired output. Okay, now we see the advantage of closed loop system. So closed loop system is more accurate operation than the open loop system, and can operate efficiently when the input or system parameters are variable in nature. For example, the input signals are varied. At the same time, it can operate more efficient compared with the open loop system, and less non-linearity effect. So in every system, we design the system, the output must be changed according to the changes of input signal. So therefore, that means the output is always follow the changes in input signal. So that is nothing but a linearity. That means the output is always depends upon the input signal. But non-linearity means the output is independent of the variations of input. So, but here in the closed loop system, less non-linearity effect. And at the same time, high bandwidth of operation. So this point is explained at the time of effects of feedback. Effects of feedback, I will explain this point, high bandwidth. Why the high bandwidth operation is done in closed loop system. I explain this point at the time of effects of feedback in a closed loop system. Then there is a facility of automation. So in closed loop system, it is easy to operate the systems automatically by using the sensors, by using the activators, and by using the control signals. So there is a facility of automation closed loop system, but it is not done in the open loop system. And another advantage is time to time recalibration. Automatically it is recalibrated because there is error signal we generate compared with the input signal. So therefore every time it can be recalibrated itself, but where it is not possible in the open loop system. Okay. Now, so here also have some disadvantages because here we add one circuit or one element, that is a feedback element. To design that feedback element is difficult. Therefore, we increase the number of elements in the system. Therefore, the system may be complex. In open loop system, it is the simple in construction because there is no additional component. Here we add additional components in terms of feedback. So therefore, the system becomes complex and it is difficult to construct. And at the same time, if you increase the number of elements in the system, the cost is also increased. So therefore, compared to the open loop system, the closed loop system is more expensive compared with the open loop system and complicated for maintenance and less stable operation than the open loop system. So generally in open loop system, the output has no effect on input, on controlling signal. So therefore it becomes stable operation. But whereas in here we generate some feedback signal or error signal. So therefore the operation of stable operation is less in closed loop system. Okay. Now here this is the difference between the open loop and the closed loop system. Here I give the tabular form. Here we can easily observe. So in open loop system, the first one is there is no feedback. There is no feedback. But whereas in closed loop system, there is a feedback system in between the output and input. But here cannot be intelligent. So here it is intelligent control action. That means the output is always depends upon the control action. We can control the output by using the controlling signal or activating signal. So here also there is no hello. Okay, there is no possibility of undesirable system oscillations. And here closed loop control system introduced the possibility of undesirable system oscillations. That means we can observe the changes in the system. Okay, so these are the so many points to compare both open loop and closed loop system. So everything is placed here, cheap and costly, simpler design and complex design. So here all these points are comprised with the help of advantages and disadvantages of open loop system and closed loop system. Okay, is it clear now? Can I move?
Yes, sir.
Hello?
Yes, sir.
Okay. Now, so these are the different examples of control system. Already some student is asked about the examples of open loop system and closed loop system. Here we have so many examples here. The first example is the temperature control system. It can be discussed with what happens in open loop system and what happens in closed loop system. We discussed both conditions. Okay, now here it is a temperature control system. That means here we use to control the temperature in electric furnace. Okay, generally the temperature is measured with the help of a thermometer, or sometimes we are using a sensors. Okay, here it is the block diagram of temperature control system. Here the black diagram is open loop. Open loop. That means here there is no path, feedback path in between the input and output. So therefore it is called as a open loop control system. Okay, here we operate this electric furnace with the help of the AC signal. So here we connect the relay control circuit which operate the electrical heater. So therefore the temperature is raised in the electric furnace and it is sensed by the temperature sensor. That means it convert the temperature, the physical quantity of temperature or analog signal to electrical signal, analog electrical signal. Okay, so the sensor is sense the temperature. The temperature is analog format. That means it is convert the analog temperature quantity to electrical analog signal, and it is fed to the A by D converter here. So in case of to process the signal, it is easy to process the signal to convert the such signals into digital signals. The processing of any signal is easy in digital format. So therefore here also the signal which is sensed by the sensor, the signal means how much amount of the temperature in the blast furnace is sensed by the sensor and it is converted into electrical signal. Then the electrical signal is converted into the digital format and it can be processed and it is interfaced with the digital display. So here we can observe the what is the quantity of the temperature here. So here this system only the display is the output here. The output is simply depends upon the sensitivity of the sensor. Okay, here there is no correction. Here by using this relay system we can heat the furnace by using of electrical coils and the temperature is sensed by the sensor and it is converted in the digital format and it is processed and it is interfaced and display in the digital display. Here there is no controlling mechanism. Simply here the system is display how much temperature in the blast furnace. There is no controlling action. Simply can measure. This is nothing but a open loop control system. Okay. Now, second one is this is nothing but a closed loop temperature control system or a closed loop temperature monitoring system. Here we have some feedback path here. So in the previous, there is no D by A converter and amplifier sections. Here the D by A converter and amplifier sections are nothing but a feedback sections. Okay. Okay. So here we have, sorry for, okay. Okay, here in the previous we have a display here. Here also we have the display, but the output is fed back to the input here. That means here the temperature in the furnace is controlled by the signal which is generated here. That means the fraction of, for example, we maintain the temperature at 100 degrees centigrade. In the previous, here we have only the temperature in the actual temperature in the blast furnace or electric furnace. So it is displayed in the display. But here we have the control system to maintain the particular temperature. For example, the temperature in the blast furnace is less than 100 degrees centigrade. So therefore, by using this mechanism or control system, we can increase the current through the electric coil. So therefore, if we increase the current through the electric coil, based on the temperature which is display on the display. So for example, if the temperature is less than the 100 degrees centigrade, so therefore we increase the current through the coil. Therefore, the temperature is raised to 100 degrees. For example, the temperature is more than that. Again, we decrease the current through the coil. That means we can control the temperature in the electric furnace by means of change of currents. The change of current is done by the controlling action. So here we have A by D converter, interfacing and controller. The controller is generating the excitation signal. Here also the excitation signal is the analog format. Therefore, we can convert that analog signal into so that digital signal into analog signal. This is a D by A converter. Here in the previous we convert this A by D. So this is reverse process, D by A conversion, and then it is amplified. And therefore here we give the excitation signal to control the current through the electrical coil. If the temperature is rise, to decrease the current through the coil. If the temperature is less, we increase the current through the coil. This is the controlling action to maintain the proper temperature in the electric furnace. Okay, is it clear? Emma? So above is the open loop system. Here there is no control. The output doesn't affect the input, or doesn't affect the controlling action. So here the output is always depends upon the control action. Okay. Now this is one example. Now we have another example. Here it is robot hand grasping force control. That means here this is the robot hand. Here the grasping, that means pick up and bear. Here the force applied and force less. So it is simply, hello? All the students are requested, please join at the time of class commencement. So in the middle, it is very difficult to allow the students. Okay, it is disturbing for me and disturbing to the class. Okay, so here it is nothing but a roboting grasp. Okay, so here if the grasping force is too weak, that means the object in the robot hand is dropped. If the force is strong, that means which is picked by the robot hand is more. That means it picked the object. If the force is less, grasping force is less, the object is dropped out. Okay, so this is a force of feedback, and this is a slip feedback. So it is one is detecting one is identify the how much force between the hands or between the fingers, and here it is nothing but a slipping feedback. Slip feedback. That means it is either it is weak or strong. So this is nothing but a robot hand grasping control system. Okay. Now it is another example, that is the speed control mechanism. So many examples we can say. So for example, out of this we can have a general example. We can have general example. For example, there are two types of washing machines. We are all very familiar. Out of these examples, we know one is the automatic washing machine, another one is the manual automation washing machine. What happens in the manual automation washing machine? What happens in the manual washing machine? We put the clothes in the drum, and the machine is washed the clothes, and we remove the clothes and put into the dryer. And something is manual. But whereas in automatic washing machine, what happened? We place the clothes in the drum, automatically sense the weight of the clothes, and as for the weight, you take the water valve is open, you take the water, and then you choke the clothes with a proper time. The time is automatically set by the programming. Then it washes the clothes in a proper time, depends upon the weight of the clothes. Then after the washing, he can sense and he dry the clothes. After that, there is a signal, acknowledged signal. The system, the process is completed. All this is nothing but a controlling action. So in the controlling action, we have used so many sensors. One sensor is sense the weight of the clothes. One sensor is sense the level of the water. One sense is the time sensing, and one is the dry time. And after completion of all the tasks, again there is a one acknowledged signal. The process is completed. we hear the buzzer. So that is nothing but a control, and all the tasks are controlled by the controlling signal with the help of sensors. Okay, here we take one example, that is the speed control mechanism. For example, already we talked about the automobile system. That means the speed of the vehicle, the speed of the automobile, the speed of the vehicle is depends upon the force applied on the accelerating or accelerator pedal. If we apply more force, the speed of the vehicle is increases. If we apply less force on the accelerator pedal, so the speed of the vehicle is decreases. So simply it is nothing but a open. Sometimes some vehicles are set by the speed limits with the help of sensors. With the help of sensor, that if the speed is over limit, the sensor can be sensed and given to the caution to the driver. So that means automatically the control is speed or control the speed of the vehicle. That is nothing but a closed loop system and with the help of sensors. So here the first speed control system James Watt developed is a fly ball generator for control the speed. So this is one fly ball. So here it is a fly ball here. So by using this we can control the speed of the engine. Speed of the engine. It recognizes the first automatic feedback control system. So this is the first automatic feedback control system to control the speed of the engine, particularly steam engine. This is developed by James Watt. So here we have, this is the fly balls here. So based on these fly balls, we can here we give the steam. So we get the pressure. It is the valve. See the slide. One minute. Okay. So here it is the valve here. So for example, you increase the force of the steam, then the valve becomes upward. So therefore, it operates the fly balls. So based on these fly balls, the speed of the engine is controlled. So the position of this fly balls is depends upon the steam and the valve here, the valve arranged here. So this is one system. This is the speed control engine. Okay. Hello? Okay, now another one is pressure control. So this is another example. Here we control the pressure. So this is an example. We have so many examples. Okay, I can send this PPT, you can read it. We can write your own examples also. Here I place some examples. We can give you your own examples in the examinations. Not only for these examples. You can give your own examples in the examinations. Okay, but here to explain some mechanism, I consider some examples. I take some examples. Okay. Now the other one is numerical control system. So this is the one of the example of either a closed loop or open loop system. For example, nowadays we use automatic door locks. We use some code, numerical code to open and close the doors, automatic doors. So that means by pressing the numbers, that numbers are converted into this analog format by using the D/A converter, and it is amplified and sent to the servo motors. The servo motors are operated as per the signal given to the motor. Okay, if the motor is operate in anti-clockwise direction, the lever is opened at the door. The motor is rotating clockwise. The lever is inside to the door. That means it is nothing but it is simple operate the opening and closing of the door by operating the motor with the help of some numerical value. So sometimes it is here we take the numerical value in the magnetic disk and it is the radar. So the output of the radar may be frequency modulated pulse and it is converted into the analog format and amplified and given to the servo motor. This is nothing but a open loop system. Now here also we have some closed loop system also. For example, here in open loop system, if you press the wrong code, it's simply not open. There is no message to you. For example, whereas in closed loop system, the pressed code is error. That is nothing but some feedback. That message alter to give the, so you press the wrong code. So in case of closed loop systems, okay, అర్థమవుతుంది కదండి. అంటే ఓపెన్ లూప్ సిస్టమ్ మనకి మెసేజ్ రిటర్న్ మెసేజ్ రాదు. అదే క్లోజ్ లూప్ సిస్టమ్ అనుకోండి, యూ ప్రెస్ ద రాంగ్ కోడ్, సో ఇట్ ఈస్ కంపేర్డ్ already stored code with the entered code. So to compare what is the code entered, what is the actual code. So compare that. So we get the message, we enter the wrong code. So in feedback system, control system, here also the same. Here we have some feedback signal. So the feedback signal is analog to digital. Then it is compared with the input signal. The input signal is the digital signal. So therefore we convert the analog signal to digital signal. Here we compare that signal and generate the error signal. And again it is converted into digital to analog and operate the servo motor. So in closed loop system, the system is always a check for we get the desired output or not. So that is the advantage of closed loop system. Emma, hello? Hello?
చెప్పండి సార్.
ఓకే, అర్థమవుతుంది కదండి.
అర్థమవుతుంది సార్.
ఓకే ఓకే ఓకే. సో
Thank you, sir.
next one is different types of feedbacks. Already we discuss about, we know about the open loop and closed loop, but in closed loop compared to the open loop system, we know already we studied so many advantages in closed loop system. In closed loop system, we need a feedback path. In closed loop system, we need a feedback path. So in feedback path, what type of feedback we arranged? That is nothing but feedback characteristics. So generally, the concept of feedback plays an important role in particularly closed loop control systems. Closed loop control system. Simply, feedback is nothing but a fraction of output is fed back to the input and generate the activating signal or error signal to operate system properly or efficiently. Okay, here if either the output or some part of output or some part of fraction of output or output is returned back to the input, to utilize that part of signal, we generate activating signal or exciting signal or controlling signal to operate the system more effective. That mechanism is called a feedback mechanism. That mechanism is called a feedback. Simply, feedback is nothing but a fraction or part of output is fed back to the input, and that feedback signal is compared with the reference signal, and we can generate excitation signal or controlling signal. Okay, now the feedback in the systems there are two types of feedbacks. One is the positive feedback and the one is the negative feedback. So here the positive feedback is nothing but the fraction of output